Hello everyone and welcome to this channel Lucid Mind Chemistry with Majid. In this video I'll be discussing Chemistry A-Levels Multiple Choice Paper 12 from February-March 2019. You can skip to any question by following timestamps given in the video description. Feel free to give any comments, likes and shares to this video. Also, you can subscribe for more upcoming videos. Let's start solving. Question number 1. The Boltzmann distribution is shown for a sample of gas at initial temperature T1. The sample of gas was heated to temperature T2. What is the correct distribution for the higher temperature T2? This question is about the Boltzmann distribution of energies. We can see that this curve shows the distribution of energy for temperature T1. When the temperature is increased, what will happen to this curve? So you have to remember a few points. First is that the area under the curve always remains constant. As we are not increasing or decreasing the number of molecules, we are just increasing the average molecular energy. When the gas is heated, the average molecular energy of the molecules will increase. So this hump will move in forward direction. So we can say that the height of the hump decreases and the height of this part of the curve will increase at higher temperature. Let's move towards the options. In A, they have given the same curve as given in the question. So there is no change in the curve, so therefore A is not the possible answer. It is incorrect. For B, you can see that hump of the curve has decreased and this part of the curve has increased. Also, the area under the curve remains constant. Now more molecules have larger energy as compared to the curve given in the previous temperature. So this could be the possible option. In C, we can see that the curve is good, but the area under the curve has also increased, which is not possible. So therefore C is incorrect. For D, we can see that the curve has moved backwards. So this is for decrease in temperature, not increase in temperature. So therefore this is also incorrect. So the only correct option is B. Question number 2. A 3.7 gram sample of copper carbonate is added to 25 centimeter cube of 2 mole per decimeter cube hydrochloric acid. Which volume of gas is produced under room conditions? Let's first write the balanced chemical equation between the reaction of copper to carbonate and hydrochloric acid. We have CuCO3. It reacts with hydrochloric acid to form salt, carbon dioxide and water. Now we can balance this chemical equation. There is one copper atom on the reactant side, one on the product side, so it is balanced. There are 2 chlorine atoms on the product side, one on the reactant side, so we can write 2 with HCl. The number of carbons is also balanced. Number of hydrogen is 2 on the reactant side and it is 2 at the product side. So the equation is balanced now. Copper carbonate is in solid form, HCl is aqueous. Copper chloride is also aqueous. Carbon dioxide is gas and water is in liquid form. In the question they are asking about the volume of gas produced, so we have to be concerned about CO2 only. Let's find the molecular mass of copper carbonate. We have CuCO3 and the molecular mass comes equal to 123.5. We can also convert 25 centimeter cube to decimeter cube, so just divide it by 1000. So we have the value 0.025 decimeter cube. Mass of copper carbonate is given, so we have to find the number of moles. Similarly, concentration of HCl is given and we have to find the number of moles of HCl and copper carbonate both. Using the formula, moles is equal to mass divided by mR. We can input the values. 3.7 grams divided by 123.5 and the number of moles of copper carbonate come equal to 0.0299 moles. For HCl, the formula used will be number of moles is equal to concentration in mole per decimeter cube into volume in decimeter cube. Putting values, we have 2 mole per decimeter cube into 0.025 decimeter cube. So the number of moles of HCl is equal to 0.05 moles. As we know that in a balanced chemical equation, the moles of product or the volume of product always depends on the number of moles of limiting reactants involved. Let's find out the limiting reactant first. From the balanced equation, we have 1 mole of copper carbonate and 2 moles of HCl, while from the given values we have 0.0299 moles of copper carbonate and 0.05 moles of HCl. Now, according to the ratio 1:2, the number of moles of HCl must be double as compared to the number of moles of copper carbonate, which is 0.0299. So therefore this is less than the double, so therefore it is the limiting reagent. Now let's find the ratio of the limiting reagent with carbon dioxide produced. So we have HCl and CO2. The number of moles of HCl in balanced equation is 2 and the number of moles of CO2 is 1. Similarly, the number of moles calculated is 0.05. So the number of moles of carbon dioxide will be X, just cross multiplied, and X will be equal to 0.05 divided by 2. So it is 0.025 mole. Now in order to find the volume, we can multiply this number of moles with 24 decimeter cube. So volume is equal to number of moles into 24 decimeter cube volume. So it comes equal to 0.60 decimeter cube. Now this is the volume of carbon dioxide that is being produced in this chemical reaction. So therefore answer is A. Question number 3. Which statement about a 3p orbital is correct? Now 3p orbital could be 3px, 3py or 3pz. A. It can hold a maximum of 6 electrons. Now we can see that only 2 electrons can be held in 3px or 3py or 3pz, so therefore this is incorrect. The 3p subshell actually contains 6 electrons. The 3p orbital contains just 2 electrons. B. It has the highest energy of the orbitals with the principal quantum number 3. We can see that with principal quantum number 3 we have 3s orbitals, 3p orbitals and 3d orbitals, and the energy of 3d is the highest among these 3. So this is incorrect. C. It is at higher energy level than a 3s orbital but has the same shape. The first part of this statement is correct because 3p has higher energy as compared to 3s, but the shape is not the same as 3s is s orbital and 3p is p orbital. S orbital is spherical in shape and p orbital is dumbbell in shape. So this is incorrect. D. It is occupied by 1 electron in an isolated phosphorus atom. Let's find out the electronic configuration of isolated phosphorus atom. We have atomic number equal to 15. So the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz. Now we have 12 electrons. The 13th will come here, 14th will come here, 15th will come on this one. Now we can see that each 3p orbital is being occupied by just 1 electron. So this is correct statement. So therefore answer is D. Question number 4. The 8 species that follow all have covalent bonds. In which pair do the species have different shapes from each other? A is beryllium chloride and carbon dioxide. We know that beryllium belongs to group 2 of the periodic table, so it just has 2 electrons in the outermost shell, and it makes covalent bond with chlorine atom, which has 7 electrons in the outermost shell. So this structure would be linear. And the bond angle is 180 degrees. Looking at carbon dioxide, we have 4 electrons in the outermost shell of carbon, and it makes a double covalent bond with one oxygen and a double covalent bond with the second oxygen. Again, when finding out the shapes, double bond is considered as a single bond, so again this is a linear structure, and the bond angle is 180 degrees. So in A, both have linear shape. So this is incorrect. B is CH4 and NH4 plus. Again, in CH4, carbon makes 4 covalent bonds. And the bond angle is 109.5. The structure is tetrahedral. In NH4 plus, what happens that nitrogen makes 3 covalent bonds with hydrogen and 1 coordinate covalent bond with H plus. Again, there are 4 atoms attached with the central nitrogen, so the structure is tetrahedral. Both have the same structure, so therefore this is incorrect. C is NH3 and BF3. In NH3, we know that nitrogen makes 3 single covalent bonds, and a lone pair is also present. Lone pair occupies quite a space, and the name of structure is trigonal pyramidal. While in BF3 there are just 3 electrons in the outermost shell of boron, so it makes 3 covalent bonds. There is no lone pair present in boron atom, so therefore the structure is trigonal planar. So in C, both have different shapes, so therefore C could be the possible answer. In D, we have sulfur dichloride and water. Now both sulfur and oxygen are from group 6 of the periodic table, so both have 6 electrons in their outermost shell. Sulfur makes 2 covalent bonds with chlorine, and 2 lone pairs are also present. The structure of water is also similar because oxygen also have 2 lone pairs of electrons and 2 single covalent bonds are being formed with hydrogen. So both structures are bent structures. So therefore D is incorrect. The only correct option is C. Question number 5. Histidine is an amino acid. This is the structure of histidine. What are the approximate bond angles 1, 2 and 3? According to valence shell electron pair repulsion theory, double bond behaves as a single covalent bond. So therefore for 1 we can see that this carbon has no lone pairs of electrons, and it is making 4 covalent bonds, out of which this bond will be considered as single covalent bond for the shape. So whenever there are 3 atoms surrounding the central element, the bond angle is 120 degrees. For second one, we can see that nitrogen is making 3 single covalent bonds, and also there is a lone pair of electron present on the nitrogen atom. So the structure will be trigonal pyramidal, and the bond angle will be reduced from 120 to 107. For third, we can see carbon. Again, carbon is present and it is making 4 single covalent bonds. There is no lone pair around carbon atom. So the structure will be tetrahedral and the bond angle is 109.5. So looking at the given options, we have 120 degree for the first one, 107 for the second one, 109.5 for the third one. So therefore correct option is B. Question number 6. A sample of gas occupies 240 cm3 at 37 degrees centigrade and 100 kilopascals. How many moles of gas are present in the sample? For solving this question, we are going to use ideal gas equation. PV is equal to nRT, or we can find the number of moles like N will be equal to pressure into volume divided by ideal gas constant into temperature in Kelvin. Let's first convert the units into appropriate ones. We have 240 cm3. For converting it into meter cube, we have to divide by 1 exponential 6. So the answer will be 240 into 10 raised to the power minus 6 meter cube. For converting temperature into Kelvin, we have to add 273. So when 273 is added to 37, it becomes 310 Kelvin. The pressure is kilopascals, so we have to convert it into pascals. So kilo means 1000. Just multiplying 1000 by 100, we get 100,000 pascals. From the data booklet, we have the value of R, which is equal to 8.314 joules per Kelvin per mole. We can also write this as 8.314 pascals into meter cube per Kelvin per mole. Now putting these values in the equation, we have 100,000 pascals pressure, 240 exponential minus 6 meter cube volume. Value of R is 8.314 pascals into meter cube per Kelvin per mole. The temperature given is 310 Kelvin. So cutting out the units, Pascal, meter cube will be cut with meter cube, per Kelvin with Kelvin. So the value of N comes equal to 9.32 exponential minus 3 mole. So therefore correct option is B. Question number 7. P, Q and R represent three different structures of an element. Which structures are giant molecular? We can see that P is graphite, Q is diamond and R is a buckyball. So all these three are the allotropic forms of carbon. Now among these three, P and Q are giant molecular structure while R is the buckyball, and a buckyball consists of 60 carbon atoms. In P and Q, as graphite and diamond, the number of atoms are not specific. Therefore the structure is giant covalent. The buckyball exists in the form of molecules. So only P and Q are having giant structure, so therefore answer is B. Question number 8. The standard enthalpy changes of combustion of carbon, hydrogen and methanol are shown. This is for carbon atom combustion, this is for hydrogen combustion, and this is the combustion of methanol. The enthalpy of combustions are also given for each of the reaction. Which expression gives the standard enthalpy change of formation of methanol in kilojoules per mole? So we have to find the enthalpy change of formation of methanol. So making a triangle out of this, we can write the chemical equation of methanol, CH3OH. It reacts with oxygen to form carbon dioxide and water. The enthalpy change of combustion for this reaction is negative 726 kilojoules per mole. Let's make a triangle and apply Hess's law. We have carbon element that is present, hydrogen as an element and oxygen as an element. So we can write carbon, hydrogen, oxygen. These elements first combine together to form the reactants, and then the reactant combusts to give the products, or these elements can directly convert into products. Balancing the number of elements with the compounds, we have 1 carbon atom, 2 hydrogen atom, and 4 hydrogen atom are in the water molecule, so we can write 2 with this one. We have 4 oxygen atoms with the product, so we can write 2 with oxygen. Now these are the elements, and elements first go into the reactants and then the reactants form the product, so therefore this is a 2-step reaction, while this one is a single step reaction. Let's name this step as X and this one as Y. Now applying Hess's law, X and minus 726 will be equal to Y. In X we can see that CH3OH is being formed from its elements, so therefore this enthalpy change will be the enthalpy change of formation of methanol. For Y we can see that carbon is being converted into carbon dioxide, so this is the enthalpy change of combustion of carbon, as 1 mole of carbon is involved, so therefore we can write minus 394 for the combustion of carbon. Also hydrogen is being converted into water, so this is the enthalpy change of combustion for hydrogen, and the value is given as minus 286. As there are 2 moles of hydrogen, so we have to multiply 2 with minus 286. This will be the enthalpy change of combustion of hydrogen. Let's put these values in the given equation. So we have X will be enthalpy change of formation of methanol minus 726 equals to Y. For Y we have 2 values. First is minus 394 for the enthalpy change of combustion of carbon. Second is the enthalpy change of combustion of hydrogen, which is 2 into minus 286. Rearranging this equation, we have enthalpy change of formation of methanol. It is equal to negative 394 plus 2 into minus 286 plus 726. So from the given options we can see that the C1 corresponds to the same calculation. So answer is C. Question number 9. The equation for a chemical reaction is shown. All substances are in their standard states. Xenon hexafluoride reacts with water to form xenon trioxide and hydrogen fluoride. Which statement describes the standard enthalpy change of reaction for this reaction? So you have to remember that for standard enthalpy change of reaction, the number of moles are not specific for chemical reaction. There could be any ratio of number of moles as long as the equation is chemically balanced. So in this equation we can see that we have 1 mole of xenon hexafluoride which reacts with 3 moles of water to form 1 mole of xenon trioxide and 6 moles of HF. So we have 4 moles in total of the reactants and 7 moles of product. Let's move towards the options. A. The enthalpy change when a total of 1 mole of product is produced. In this reaction there is 7 moles of product being produced, so therefore this is incorrect. B. The enthalpy change when a total of 1 mole of reactants is reacted. As the number of moles are not specific, in this reaction there are 4 moles of the reactants being reacted, so this is also incorrect. The enthalpy change when 1 mole of water reacts. In this equation we can see 3 moles of water is being reacted, so this is also incorrect. D. The enthalpy change when 6 moles of hydrogen fluoride are produced. So in this chemical equation we can see that 6 moles of HF are being produced, so therefore this corresponds to this chemical equation. So the answer is D. Question number 10. Acidified potassium manganate 7 reacts with iron 2 ethane diOH. The reaction taking place are shown. How many moles of iron 2 ethane diOH reacts with 1 mole of potassium manganate? They have given us potassium manganate and iron 2 ethane diOH. Let's find the oxidation states. Iron is +2 as they have given in this equation, and overall the molecule is neutral, so therefore the charge on ethane diOH will be -2. The reaction of ethane diOH is given. It converts into carbon dioxide and releases 2 electrons. The reaction of iron +2 is also given. It converts into iron +3 and loses 1 electron. So both these reactions are oxidation, as electrons is being lost. In this reaction of manganate iron we can see that 5 electrons are being gained, so therefore this is reduction equation. So in order to balance this chemical equation, the number of electrons lost must be equal to the number of electrons gained. In reduction 5 electrons are involved, while in oxidation 1 + 2, so total 3 electrons are involved. So in order to balance 3 and 5, we can multiply the first equation with 3, so it becomes 15 electrons. And we can also multiply these two equations with 5, so it also becomes 15 electrons. After multiplying we can write 3 MnO4 negative reacts with 24 H plus and 15 electrons to give product. For the second equation we can write 5 Fe plus 2 reacts to give product. C2O4 is also multiplied by 5, so we can write 5 C2O4 negative 2 gives product. I'm not writing the product because in the question they have given iron 2 and KMnO4, so we just have to find out the number of moles of MnO4 and iron plus 2. Upon adding all these three equations we can get 3 moles of MnO4 negative reacts with 5 moles of iron plus 2, 5 moles of C2O4 negative plus 24 moles of H plus 15 electrons and gives product. So the only concern is with MnO4 negative and iron plus 2. So we can write MnO4 negative, iron plus 2. The molar ratio according to the balanced equation is 3 to 5. In the question they have asked about 1 mole of potassium manganate, so if it is 1 then this will be X. Cross multiplying we have 3x is equal to 5, or x is equal to 5 divided by 3, which is equal to 1.67 moles. So therefore answer is B. Question number 11. When copper is added to a solution of silver ions, the following equilibrium is established. What is the concentration of silver ions at equilibrium when copper plus 2 is equal to 0.10 mole per decimeter cube? The Kc for this chemical reaction is given as 1 exponential 5. As we can see in this chemical equation that copper is in solid form and silver is also in solid form, so this will not be a part of Kc equation. Using the formula of Kc, we have Kc is equal to the concentration of product, which is copper plus 2, divided by concentration of reactants, which is silver plus, raised to the power their number of moles. So silver ion has 2 moles while copper ion has just 1 mole. Solid is never a part of Kc equation, so therefore we are omitting silver and copper. As we have to find the concentration of silver ions, so we can write Ag plus square is equal to copper plus 2 divided by Kc. Now putting the values, we have 0.10 mole per decimeter cube concentration of copper, and the value of Kc is 1 exponential 5, so it is equal to 1 exponential minus 6 mole per decimeter cube. So the concentration of silver ions is equal to 1 exponential minus 6 mole per decimeter cube. Taking under root on both sides, we have Ag plus concentration will be equal to 1 exponential minus 3 mole per decimeter cube. So therefore correct option is C. Question number 12. X, Y and Z are elements in period 3 of the periodic table. The results of some experiments carried out with compounds of these elements are shown in this table. So we have X. First is the resulting addition of oxide to water. Second is the adding of chloride to water. Third is the result of adding oxide to HCl. Which statement could be correct? Finding out the first one, A says X is aluminum. So the result of adding the oxide of aluminum to water, there is no reaction, as aluminum oxide is insoluble in water. So there is no chemical reaction. So therefore this is correct for aluminum. Now the second reaction is of aluminum chloride with H2O. So we can write AlCl3 plus H2O. This reaction is a hydrolysis reaction in which aluminum plus 3 is formed along with H plus ions. The third is the reaction of oxide with HCl. So aluminum oxide reacts with HCl to form salt and water. So X is aluminum, this is correct. Y is magnesium. So finding out the reaction of magnesium with water, it forms magnesium hydroxide. So this is true for magnesium. Magnesium chloride reaction with water, it dissolves. Magnesium chloride is water soluble, so therefore this is also correct. Third one is that magnesium oxide reacts with HCl to form salt, as magnesium chloride salt is formed, so therefore this is also correct for magnesium. So X could be aluminum and Y could be magnesium. Moving towards option B, X is silicon. First is there is no reaction of silicon dioxide with water. This is true. Second is that silicon chloride will hydrolyze in water. SiCl4 reacts with water to form silicon dioxide and HCl. So this is also true for silicon. Third is that the oxide of silicon reacts with HCl to form chloride. So silicon dioxide plus HCl, as silicon dioxide is acidic in nature and HCl is also acidic in nature, so the reaction will not occur. So therefore B is incorrect. For option C, it says Y is aluminum. Aluminum oxide forms hydroxide with H2O, so this is incorrect, as aluminum oxide is insoluble in water and it does not react. D says Y is sodium and Z is aluminum. Finding out the reaction of sodium in Y, we have sodium oxide plus water, it forms sodium hydroxide. So this is correct for sodium. Second is NaCl is soluble in water, as we know that NaCl is a common salt, so it is soluble in water to form sodium ions and chloride ions, so it is also true for the second one. Third is that the oxide of sodium will react with HCl to form chloride. So Na2O is basic in nature, it will react with acid to form salt along with water. So this is correct for sodium. So Y is sodium is correct. Then let's move towards Z. Z is aluminum. The first one is that aluminum oxide reacts with water to form acid. As we know that aluminum oxide does not react with water, so therefore this is incorrect. So therefore the only correct option is A. Question number 13. A solid period 3 element Q is reacted with oxygen gas. A compound R is formed. When R is added to water, the pH decreases. What could be the empirical formula of R? In the question, they have given a solid from period 3 which forms oxide upon reaction with oxygen gas, and compound R is actually oxide of period 3. In period 3 we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. All of them are solids except chlorine, so therefore chlorine is not element Q. Second point is that when R is added to water, the pH decreases. It means that the oxide that is formed is acidic in nature. Acidic oxide is the oxide of non-metal oxides. So it means it is not sodium, it is not magnesium. As these are basic oxides, the oxide of aluminum is amphoteric in nature, so it is not aluminum oxide. So only options left are silicon, phosphorus and sulfur. If it is silicon, then silicon reacts with oxygen to form SiO2. If it is phosphorus, it reacts with oxygen to form P4O10. If it is sulfur, it will react with oxygen to form sulfur dioxide or sulfur trioxide. Now we can write the empirical formula considering these elements as Q. So the empirical formula for SiO2 will be QO2, as it is the simple ratio 1:2 and it cannot be simplified further. For second one it will be 2:5, so the compound formed will be Q2O5. For third one it will be QO2 or QO3. Let's look at the given options. We have this one similar. This is not the empirical formula, it is the molecular formula. So therefore option B is correct. Question number 14. Metal T reacts with water to produce a colorless solution. A white precipitate is produced when this colorless solution is mixed with aqueous sulfuric acid. What is metal T? Let's look at the options. A is barium. Barium reacts with water to form colorless solution of barium hydroxide. So this is true. Barium hydroxide reacts with sulfuric acid to form precipitate of barium sulfate. So both options are correct for barium, so it could be the possible answer. B is magnesium. Magnesium reacts with water to form magnesium hydroxide. And this is not a colorless solution. And magnesium hydroxide reacts with sulfuric acid to form magnesium sulfate, which is a soluble solid. So therefore option B is incorrect. C is potassium. Potassium reacts with water to form a colorless solution of potassium hydroxide. Potassium hydroxide reacts with sulfuric acid to form potassium sulfate, which is soluble. So therefore option C is also incorrect. For sodium, we have sodium hydroxide in water and sodium sulfate in sulfuric acid. Again, sodium sulfate is soluble, so therefore D is also incorrect. The correct option is barium A. Question number 15. When calcium nitrate thermally decomposes, oxygen is one of the products. Which volume of oxygen is produced under room conditions when 0.50 moles of calcium nitrate thermally decomposes? Let's first write a balanced chemical equation for decomposition of calcium nitrate. So we have CaNO3 twice. When it is heated, it forms calcium oxide, nitrogen dioxide, and oxygen gas. After balancing, the molar ratio comes to be 2 to 4 and 1. So we have calcium nitrate and oxygen given in the question. The molar ratio according to the balanced equation is 2:1. So we can write 2:1. In the question they have given 0.5 moles of calcium nitrate. So for 0.5 it will be X, just cross multiply. So 2X is equal to 0.5, or X is equal to 0.5 divided by 2, which is equal to 0.25 mole. Converting moles of oxygen into volume, we have the formula of volume in decimeter cube is equal to number of moles into 24 dm cube. So it is 0.25 into 24, and the answer is 6 decimeter cube. So A is the correct option. Question number 16. L, M and N are group 2 metals. L reacts more vigorously with dilute hydrochloric acid than N. M hydroxide is more soluble than N hydroxide. What could be the identities of L, M and N? In this question they have given just 3 elements: calcium, strontium and barium. So according to group 2 sequence we can write them as calcium, then strontium, then barium. The reactivity of group 2 increases down the group. As in the question it says L reacts more vigorously than N, so therefore it means L is below N. We also know that the solubility of hydroxide of group 2 metals down the group increases. In the question they say that M hydroxide is more soluble than N hydroxide. It means M is below N. So as N is both above L and M, so we can say that N could be calcium. Let's look at the options. In N we have strontium, calcium, strontium, barium. So therefore correct option is B. Question number 17. The table shows some reactions of a white compound G. This is the test and this is the observation. What could be the identity of G? In the test it says silver nitrate is added to a solution of G followed by aqueous ammonia. First a precipitate is formed and then the precipitate does not dissolve when ammonia is added. For second test, we have solid G which is warmed with concentrated sulfuric acid, and first a mixture of gases is formed including hydrogen sulfide. Let's find out the options. First, let's look at the reactions of anions. We have chloride, bromide, sulfate and iodide. So we can write chloride, bromide, iodide and sulfate. For first test, silver nitrate is added, so we add silver nitrate. What happens with these is that silver chloride, silver bromide, silver iodide and silver sulfate are formed. The color of these is white, cream, pale yellow and again white. For second part, it says it is followed by aqueous ammonia. So when aqueous ammonia is added, silver chloride dissolves, silver bromide is insoluble, silver iodide is also insoluble, silver sulfate dissolves. For sulfate, the reaction is given here. For iodide, the reaction is given on this side. So according to the observation given in the question, it could be bromide or iodide. So therefore, lithium bromide is the possible option, or sodium iodide is the possible answer. For second test, we have solid G which is warmed with concentrated sulfuric acid. Let's look at these options B and D. Lithium bromide, when reacts with concentrated sulfuric acid, it forms HBr, bromine gas and sulfur dioxide gas. But when sodium iodide is added to concentrated sulfuric acid, it forms hydrogen iodide gas, iodine, sulfur dioxide and hydrogen sulfide. As in the observation, they have mentioned hydrogen sulfide, so therefore this option is correct. So the answer is D. Question number 18. Under standard conditions, which statement is correct? So we have to find out the correct statement among these. First is that chlorine aqueous can oxidize bromide ion. Second is reducing. C says chloride ion can oxidize bromine. D says chloride aqueous can reduce bromine. We can write chemical equation for these reactions, and we will write NaBr instead of Br negative. Now the reaction of NaBr with chlorine aqueous. As sodium has positive charge and bromide has negative charge. Now this reaction is possible because chlorine is more reactive than bromine, so it will displace bromine and form NaCl along with bromine aqueous. In this equation, the oxidation state of Br has changed from -1 to 0. So from -1 to 0 is oxidation. So for part A, chlorine can oxidize Br negative, so this seems to be true. B is chlorine aqueous can reduce Br negative, as Br negative is being oxidized, so therefore this is incorrect. For C, we have chloride ions can oxidize Br2. Let's write a chemical equation for this one. So we can write NaCl instead of chloride, as it has -1 charge, plus Br2 aqueous. As we know that bromine is less reactive than chlorine, so it cannot displace this, so therefore the reaction will not occur. So neither oxidation will take place nor reduction. So the correct option is A. Question number 19. Ammonia, NH3 and hydrazine, NH2 are two compounds of nitrogen. Which statement is correct? A. The nitrogen-nitrogen bond in NH2 is polar. Let's draw the structure of NH2. We have two nitrogen atoms, two hydrogen atoms with one nitrogen, and two hydrogen atoms with the second nitrogen atom. As nitrogen belongs to group 5, so it has 3 electrons in the outermost shell that are involved in bonding, while 2 electrons are present in the form of lone pair. Same for this nitrogen. As we can see that both nitrogen atoms are singly bonded with each other and both have same electronegativity as it is the same element. So therefore this bond is non-polar. So option A is incorrect. Part B. NH3 and NH2 have lone pairs of electrons, but nitrogen does not. Let's see, in NH3 nitrogen makes 3 single bonds with 3 hydrogen atoms and 2 electrons are present in the form of lone pair. In nitrogen molecule, what happens that nitrogen makes triple covalent bond with another nitrogen and lone pair is present. So therefore option B is incorrect. C. The oxidation number of each nitrogen in NH2 is +2. We can write NH2 in the form of N2H4. Overall, the charge on this molecule is 0. As nitrogen is more electronegative than hydrogen, so therefore the charge on nitrogen is negative. We have 2 nitrogens, 4 hydrogens equal to 0. The oxidation state of one hydrogen is +1. So for 4 hydrogen it will be +4, or 2 nitrogen is equal to -4, or for single nitrogen we would have -2. In the question it says +2, so therefore this is also incorrect. Part D. The reaction of nitrogen with hydrogen has a high activation energy. Nitrogen reacts with hydrogen to form ammonia. As we know that this is a reversible reaction and there is triple bond in nitrogen molecule and single bond in hydrogen molecule, so a lot of energy is required to break this triple bond and this single bond in order to make NH3. So therefore the activation energy of this reaction is quite high. So option D is correct. Question number 20. How many structural isomers are there of trichloropropane? We have C3H5Cl3. Let's draw the possible structural isomers. We have 3 carbon atoms, 1, 2, 3, and 3 chlorine atoms. Now chlorine atom can attach with hydrogen atom in a different manner. It could be like this. It makes 1, 2, 3 trichloro propane, or it could be like this. The name would be 1,1,2 trichloropropane. We could also have this structure where all the 3 chlorine atoms are joined with first carbon atom. So the name would be 1,1,1 trichloropropane. Also we can have 1 chlorine atom attached with the last carbon. So it will become like this. Now the name is 1,1,3 trichloropropane. In another structure we can have 2 chlorine atoms attached with the central carbon and 1 chlorine atom attached with the first carbon. So it could be like this, 1, 2, 2 trichloropropane. Now we have 5 different structural isomers and no other structural isomer is possible, so therefore answer is C. Question 21. Compound L has the molecular formula C10H16. A sample of L reacts with an excess of hot, concentrated, acidified potassium manganate. Compound M is produced. What could be the structure of compound L? In the structure of M, we can see that this part is ketone, as this carbon has 2 carbon atoms attached directly. This carbonyl carbon is also from ketone, while this third is carboxylic acid functional group. In options A, B, C and D, we can see that there are 2 types of bond. One is single covalent bond and the other is double covalent bond. And single covalent bond is not oxidized by hot concentrated acidified potassium manganate. Only double bond is oxidized. So for oxidation of alkenes, you should remember whenever an alkene is having 2 alkyl groups with double bonded carbon, so this will convert into ketone. If one of the group is alkyl in alkene and the other group is hydrogen with the double bonded carbon atom, then this will convert into aldehyde. And it is further oxidized to carboxylic acid. If the double bonded carbon atom has 2 hydrogen atoms, then it is converted into CO2. Now looking at option A, we have this carbon which is making a double bond, and this carbon has 2 alkyl group attached. So therefore this bond will break and this carbon will make a ketone. This carbon has a double bond and it has 1 alkyl group and 1 hydrogen atom attached. So this will convert into aldehyde and then carboxylic acid. We have 2 more carbon atoms with double bond. One is this. It has 2 alkyl groups directly attached. So upon oxidation, this bond will break and it will convert into ketone. This carbon has just 2 hydrogen atoms attached with it, and upon the breaking of double bond, it will convert into carbon dioxide. In B, we can see this carbon atom makes a ketone. This carbon atom will make carboxylic acid, as discussed in the previous one. This carbon atom has 1 alkyl group directly attached and 1 hydrogen atom. So this will first convert into aldehyde and then into carboxylic acid. This carbon is also making double bond and it has 1 alkyl group directly attached. So it will first convert into aldehyde and then into carboxylic acid functional group. In part C, we have this carbon which is making double bond, and this carbon has 1 alkyl group directly attached and the other is hydrogen atom. So upon oxidation, this double bond will break and this carbon atom will convert into aldehyde first and then go into carboxylic acid. Again, this carbon atom also has a double bond and 1 alkyl group directly attached. The other element is hydrogen. So it will also first convert into aldehyde and then further oxidize into carboxylic acid. Now this carbon atom has 2 alkyl group directly attached. So it will convert into ketone. And this carbon atom has 2 hydrogen atoms attached with it. So it will form carbon dioxide. In part D, again we have this carbon and this carbon. Both will convert into carboxylic acid. This carbon and this carbon. These both will also convert into carboxylic acid functional group. In the structure of M, we can see we have 2 ketone functional groups and 1 carboxylic acid functional group. So in these 4 options, you can see that we have 2 ketones and 1 carboxylic acid functional group, which is just made by the structure A. So therefore A is the correct option. Question number 22. Many reactions take place in the engine and catalytic converter of a car. Which pair of substances is produced both by reactions in car engine and in a catalytic converter? Now we know that in car engine combustion take place, and in the result of combustion we have carbon dioxide, water, carbon monoxide, and unburnt hydrocarbons are produced. In catalytic converter, what happens that the unburnt hydrocarbons are converted into carbon dioxide and water, and nitrogen compounds are converted into nitrogen gas. Now we can see that the common compounds among these are CO2 and H2O. So therefore answer is B. Question number 23. Structural isomerism and stereoisomerism should be considered when answering this question. 2-bromopentane is heated with an excess of ethanolic sodium hydroxide. How many different hydrocarbons are produced? In stereoisomerism, we have cis-trans isomerism as well as optical isomerism. 2-bromopentane is halogenoalkane, and when it is heated with an excess of ethanolic sodium hydroxide, it causes elimination reaction. Let's write the equation for this reaction. We have pentane, which consists of 5 carbon atoms. On second carbon we have bromine atom attached, so it is 2-bromopentane. I'm not writing hydrogens. In the presence of sodium hydroxide, ethanolic elimination will occur, and the products formed are alkene. In this case we have 5 carbon alkane, so there will be 5 carbon alkene, which is pentene, along with water and sodium bromide. Now let's find out the possible structures of pentene that are being produced. So elimination can occur between first and second carbon, where hydrogen is removed from first carbon and bromine is removed from second carbon. Or elimination can also occur between second and third carbon, where bromine atom is removed from second carbon and hydrogen is removed from the adjacent third carbon atom. So the pentene formed will be like this. For the first possibility, and like this for the second one. The names of the products are pent-1-ene and pent-2-ene. These are the only 2 possible structural isomers of the product. Now let's find out whether there is stereoisomerism present or not. So let's look at the cis-trans first. We have 2 hydrogen atoms with this carbon, which is double bonded. So therefore this compound cannot give cis-trans isomerism, as the rule is that the double bonded carbon must have 2 different elements or compounds attached. For the second compound, we can see that this carbon, which is double bonded, has an hydrogen atom. Similarly, this one also have a hydrogen atom. So both these carbons have different elements or compounds attached with itself. So therefore pent-2-ene can show cis-trans isomerism. So we could have cis pent-2-ene, which would be like this, or trans-pent-2-ene, the structure would be like this. The first one is cis, as similar atoms are on the same side. The second one is trans, as similar atoms are on the opposite side. So in total we have 3 different types of pentene being formed. First one is pent-1-ene, second is cis-pent-2-ene, and third is trans-pent-2-ene. So therefore answer is C. Question number 24. Bromopropane reacts with water as shown. This is the chemical reaction. We can see that bromine is being replaced by OH. Which statement is correct? A. This is an elimination reaction. As we know that Br is being replaced by OH, so this is not elimination, it is substitution. For elimination, we would need sodium hydroxide ethanolic. B. This is a hydrolysis reaction. What happens in hydrolysis is that water molecule breaks into H and OH, and then OH replaces Br to give alcohol. As the name indicates, hydro is for water, lysis is for breakdown, so this could be the possible option. C. This is a redox reaction. So in redox reaction, both oxidation and reduction takes place. We cannot see whether any oxidation or reduction would have occurred, as Br is -1 on both sides, OH is -1 on both sides. So therefore this is not a redox reaction. D. This reaction tends to proceed via the SN1 mechanism. Now SN1 means nucleophilic substitution reaction. SN1 is followed by tertiary halogenoalkanes. The halogenoalkane given in this reaction is the one in which Br is attached to this carbon atom, and this carbon is further directly attached with one carbon atom, so therefore it is primary halogenoalkane. So part D is also incorrect. The only correct option is B. Question 25. Which product is formed when 3-methylpentane 1,3,4-triol is heated under reflux with an excess of acidified potassium dichromate 6? Let's first draw the structure of this compound. We have pentane, so it means we have 5 carbons with single bonds. We can number them 1, 2, 3, 4, 5. I'm not drawing hydrogen for the sake of easiness. Now on third carbon atom we have methyl, so it is CH3. On first, third and fourth carbon we have triol. Tri means 3 and ol is from alcohol, so there are 3 OH groups. One is on first carbon, second is on third carbon, and third is on fourth carbon. Now we have 3 types of alcohol. The first one is primary alcohol, as this OH is attached to this carbon, which is further attached with one carbon atom. So this is primary alcohol. Second alcohol is the one in which OH is attached with this carbon, and this carbon is further attached with 3 other carbon atoms directly. So this is tertiary alcohol. The third alcohol is attached with this carbon, which is directly attached with 2 other carbon atoms, so it is secondary alcohol group. Now in the presence of excess acidified potassium dichromate, oxidation will occur and primary alcohol goes into aldehyde first and then moves towards the carboxylic acid. Tertiary alcohol is not oxidized. Secondary alcohol goes to ketone. So let's draw the possible product that is formed after oxidation. We have 5 carbon atoms. The first carbon is oxidized to carboxylic acid, so it will become COOH. The third carbon atom will remain as it is, so it would have one OH group and one CH3 group. While the fourth carbon atom will convert into ketone, so it will have double bond O. Now let's draw the missing hydrogen atoms. We have 2 hydrogen with this carbon, no hydrogen with this one, no hydrogen with this one, and 3 hydrogen with the corner carbon atom. Let's write the formula of this product as given in part A, B, C and D. So we have HOOC, then we have CH2, then we have carbon atom. As OH and CH3 both are attached with this carbon atom, so we'll write them in brackets. One will be CH3, the other will be OH. Then we have carbonyl carbon, and then in the last we have CH3. So we can match this product with A, B, C and D. And in A we can see we have COOH, then CH2, then carbon atom with 2 substituents, carbonyl carbon and CH3. So therefore A is the possible answer. Question 26. Menthol is naturally occurring alcohol. So this is the structure of menthol. When menthol is heated with concentrated sulfuric acid, it reacts. The products formed include compound T. What could be the structure of compound T? Now what happens when concentrated sulfuric acid reacts with alcohol? It actually removes water molecule or dehydration occurs. Now in the removal of water, OH will be removed from one carbon atom, which is this one, and hydrogen will be removed from adjacent carbon atom, which could be this carbon or this carbon. So after elimination we have 2 possible products. Water is removed. The first product would be like this. Where hydrogen is removed from this carbon atom, so therefore the double bond will come between these 2 carbons. Or the second product will be like this. Where hydrogen is removed from this carbon, so double bond would come between these 2 carbon atoms. We can give numbers to carbon. This is first carbon, this is second one, third one, fourth one. In this structure we have first carbon, then second, then third, then fourth. Now we can see that double bond is between third and fourth, or it could be between fourth and fifth carbon. Let's look at the products. In the products we have double bond between fifth and sixth, which is not possible. In B we have carbonyl carbon, which is not possible. In C the double bond is between second and third carbon, which is also not possible. In D we have double bond between fourth and fifth carbon. So therefore D is the correct option. The structure of D is exactly similar to the one that we have formed in the product. Question 27. Structural isomerism only should be considered when answering this question. All the isomeric alcohols with the molecular formula C5H12O are added separately to warm alkaline aqueous iodine. How many of the isomers give a yellow precipitate? Now alkaline aqueous iodine will give the positive results with only those alcohols that have methyl group directly attached to the carbon atom which is attached with OH functional group. If there is no methyl with the carbon atom having OH group, then there will be no positive result. Let's draw possible structural isomers of C5H12O and let's see which one have methyl group attached with the carbon atom having OH functional group. As we have 5 carbon atoms, 1, 2, 3, 4, 5, OH could be attached with the first carbon which is primary alcohol. So this has no methyl directly attached, so therefore this won't give positive result. There are other possibilities of this structure. We can draw them as this, where one of the substituent is on third carbon atom. Again, in the third possible structure we have OH attached with the first carbon which is attached to the second carbon, and there are 3 substituents present on the second carbon atom. Again, this does not has any methyl group attached directly with this carbon, so therefore this won't give positive iodoform test. All these 3 structures were from primary alcohols. Now let's move towards secondary alcohols. In secondary alcohol, OH is attached to the carbon atom which is further attached with at least 2 carbon atoms directly. Now in total we have 5 carbons, so it could be like this, or it could be like this, or another possibility is that there is a substituent attached with the third carbon. All these 3 are secondary alcohols. Let's see which one has methyl group directly attached to the carbon atom with OH. So this is the carbon atom with OH. It does not have any methyl group, so this won't give positive result. This is the carbon attached with OH and it does have a methyl group directly attached, so this will give positive iodoform test. Again, this carbon does have a methyl group, so this will also give a positive iodoform test. Now moving toward tertiary alcohol structures, we have OH which is attached to the carbon atom which is directly attached to 3 other carbon atoms, and as there are 5 carbons in total, so we can draw like this. This is the only possible structure for tertiary alcohol. In this structure we can see that the OH is bonded to this carbon which is directly attached to 2 methyl group and 1 ethyl group. As we need just 1 methyl group directly attached to this carbon, so therefore this won't give positive iodoform test. So we only have 2 possible structures that give positive iodoform test. First one is pentane 2-ol, and second one is 3-methyl butane 2-ol. So therefore correct option is 2. Question number 28. When compound X is heated with dichromate in the presence of acid, a color change from orange to green is observed. 2 tests are carried out on the organic product of this reaction. The test is the tolerance reagent and result is no change. Second test is 2,4-DNPH and result is orange precipitate. What could be compound X? You should know that tolerance reagent gives positive result with aldehydes, and 2,4-dinitrophenylhydrazine gives positive result with both aldehydes and ketones. So as compound X does not give any change with tolerance reagent, so it means it is not aldehyde, it could be ketone. The functional group of aldehyde is RC double bond OH. 2,4-DNPH gives positive result, which means that carbonyl carbon is present and it could be a ketone. Now, according to this test and result, we know that the product is a ketone, but in this question they have asked about the reactant, not the product, so let's see which reactant gives a ketone. Moving towards options, in A we have carbonyl carbon with 2 alkyl groups attached, so it is already a ketone and it won't be further oxidized. In B we have aldehyde functional group and it will be further oxidized to carboxylic acid. In C we have carboxylic acid functional group and it is not oxidized any further. In D we have secondary alcohol group, as 2 alkyl groups are attached with the carbon atom attached to OH, so therefore this will be oxidized to ketone. So the only option that can give a ketone is D. Question number 29. 1 mole of each of the following 4 compounds is reacted separately with number 1 an excess of sodium, number 2 an excess of sodium carbonate. Which compound produces the same volume of gas with each of the 2 reagents? Let's move towards the options. In A we have alcohol functional groups. Now alcohols does react with sodium to form sodium alkoxide. Along with hydrogen gas. But alcohol does not react with sodium carbonate. So therefore A is incorrect. Let's move towards B. In B we have 2 functional groups. One is carboxylic acid, second is alcohol. Now in B both functional groups react with sodium to form sodium alkoxide and sodium salt. So the structure would be like this: ONA, C double bond O, ONA. And a hydrogen molecule will be formed. Now reacting with sodium carbonate, only carboxylic acid functional group will react with sodium carbonate and OH is not going to react with sodium carbonate, so the product will be in these reactions we can see that with sodium 2 hydrogen atoms are removed, one is this one and one is this one, so 1 mole of hydrogen is being produced as gas. But in the reaction with sodium carbonate we have water formed. Now water has 2 hydrogen atoms while only 1 hydrogen atom is being removed in this reaction, which forms O negative and Na positive. So in order to balance the reaction with sodium carbonate we would need 2 moles of B to form H2O. As carbon dioxide is in gaseous form and H2O is in liquid form, so we can say that 2 moles of compound B produces 1 mole of carbon dioxide, but in the question they have given 1 mole of reactant. So 1 mole of compound B will give half moles of CO2. So on one side we have 1 mole of hydrogen being produced on the reaction with sodium, and on the other side we have half mole of CO2 being produced on reaction with sodium carbonate. So the volumes are not equal, so therefore B is incorrect. In C we have two functional groups, one is aldehyde, second is OH functional group. On reaction with sodium, aldehyde does not react, only OH reacts. So the product will be like this. As we have 1 mole of the reactant involved, so only 1 mole of H is being produced. Second reaction is with sodium carbonate. So none of these react with sodium carbonate and there is no chemical reaction, so therefore no gas is produced. So C is also incorrect. In D we have two carboxylic acid functional groups. Let's first react them with sodium metal. The product will be like this. One hydrogen has been removed from this oxygen, one being from this oxygen. So molecule of hydrogen will be produced. Second reaction is with sodium carbonate. Now this product is going to be produced. Again, one hydrogen atom is being removed from this part, one from this part. So we have H2O along with CO2. So we can see that when 1 mole of reactant is used, 1 mole of hydrogen gas is produced in the first reaction and 1 mole of CO2 is produced in the second reaction. So both have equal number of moles of gas, so therefore D is the correct option. Question number 30. An infrared spectrum shows a broad peak at 3000 per centimeter and a strong peak at 1710 per centimeter. Which substance could have produced this spectrum? Now let's look at the data booklet. We can find that in carboxylic acid, oxygen-hydrogen bond will produce a peak between 2500 to 3000 per centimeter, and it is sharp and broad, very broad. Again, from data booklet we can see that if carbonyl carbon is from carboxylic acid, so then it will give peak between 1680 to 1730 per centimeter, and it's a strong peak. So both these peaks at 3000 and 1710 correspond to carboxylic acid functional group. So therefore A is ester, B is alcohol, C is carboxylic acid and D is ketone. So the possible option is C. Question 31. In an experiment, 10 cm³ of an organic compound J in the gaseous state is reacted with an excess of oxygen. Steam 20 cm³ of carbon dioxide and 5 cm³ of nitrogen are the only products. All gas volumes were measured at same temperature and pressure. What could be the identity of J? Let's write the equation for J. In the question they say that J reacts with an excess of oxygen gas to form steam, carbon dioxide and nitrogen. Also the volumes are given. 10 cm³ of compound J is used. 20 cm³ of CO2 is being produced and 5 cm³ of nitrogen is being formed. As all components of this chemical reactions are in gaseous form, J is gas, oxygen is gas, water is in steam form, carbon dioxide is gas, nitrogen is also gas. So we can write volumes as number of moles. 10 mole of J reacts with excess moles of oxygen to form 20 moles of CO2 along with 5 moles of nitrogen. We can simplify these 3 moles as to simple ratio. We would have 2 moles of J reacts with 4 moles of CO2 to form 1 mole of nitrogen. This can further be simplified to 1 ratio 2 ratio 0.5. So we can say 1 mole of J reacts with excess oxygen to form 2 moles of CO2 and 0.5 moles of nitrogen. So now, according to balanced equation, in 1 mole of J we must have 2 carbon atoms and 1 nitrogen atom. So it could be option 2, which has 2 carbon atoms and 1 nitrogen atom, and also option 3, which has 2 carbon atoms and 1 nitrogen atom. So therefore option 2 and 3 are correct. So therefore answer is C. Question number 32. In which pairs do both species have the same number of unpaired electrons in p orbitals? Let's first find the number of electrons. Oxygen atom has 8 electrons. Chlorine positive has 16 electrons. F positive has 8 electrons. Gallium negative has 32 electrons. Atom has 7 electrons. Krypton has 33 electrons. Now let's do the electronic configuration of oxygen. We have 1s2, 2s2, 2px, 2py, 2pz. As 4 electrons are filled and there are 4 electrons that are left, so we would have 1 electron in X, 1 in Y, 1 in Z, and then 4th electron in 2px orbital. For Cl positive we can write 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz. Now putting electrons, we have 12 electrons already filled and 4 electrons are left. So 1, 2, 3, and then the pairing starts 4. Now in oxygen atom we can see that in 2p orbital we have 2 unpaired electrons. In chlorine positive we also have 2 unpaired electrons present. So 1 is the correct option. Now moving towards second option, we have F positive. As fluorine positive has 8 electrons, so the electronic configuration will be exactly similar to oxygen atom. So it has 2 unpaired electrons. Now for gallium 32, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4px, 4py, 4pz. As we already have filled 30 electrons up till 3d10, so now we just have 2 electrons left. One will be in 4px, one will be in 4py. So we can see there are 2 unpaired electrons in gallium negative and there are 2 unpaired electrons in fluorine positive. So option 2 is also correct. Moving towards option 3, we have nitrogen 7. So the electronic configuration will be 1s2, 2s2, 2px, 2py, 2pz. As 4 electrons are already filled, so we have 3 electrons left, 1, 2, 3, and there are 3 unpaired electrons present in p orbitals. Now for krypton plus 3, we have 33 electrons, so the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Then we have 4px, 4py, for PZ, as 30 electrons are already filled up till 3d10, so there are 3 electrons that are left. 1, 2, 3. Again we have 3 unpaired electrons, so 3 is also correct option. As all 3 options are correct, so therefore answer is A. Question 33. In which reactions is the underlined element or compound reduced? In first option we have NaClO and Cl is underlined, as the oxidation state of oxygen is -2 and of sodium is +1, so therefore the oxidation state of Cl will be +1. In the product we have NaCl and the oxidation state of Cl is -1 and of sodium is +1. So the change in oxidation state from +1 to -1 is reduction. So therefore option 1 is correct. In option 2 we have nitrogen being underlined and it is NH3, as nitrogen is more electronegative than hydrogen, so therefore the total oxidation state of 3 hydrogen atom will be +3, and on 1 nitrogen atom it would be -3. In product we have lithium atom, so the oxidation state is +1. There are 2 hydrogen atoms, so the total oxidation state on 2 hydrogen will be +2. As the molecule is overall neutral, so therefore the number of positive charges will be equal to the number of negative charge, so the charge on nitrogen is -3. So -3 to -3 is no change, so therefore it is not reduction. In third option we have this compound being underlined, it is primary alcohol. And we can see that this compound is being produced, which is aldehyde. We know that primary alcohol oxidizes into aldehyde. So therefore this is oxidation, not reduction. So the only possible option is 1 and the answer is D. Question 34. Some polluting gases are removed from car exhaust fumes using a catalytic converter. Platinum or palladium can be used as the catalyst. The reactions are faster when platinum is the catalyst than when palladium is the catalyst. Which statement are correct? Number 1. Platinum acts as heterogeneous catalyst in these reactions. We know that in catalytic converter all reactants and products are in gaseous state, and platinum is in solid form, so therefore it is a heterogeneous catalyst. So option 1 is correct. In option 2, the palladium catalyzed reactions have high activation energy than the platinum catalyzed reactions. As in the question they have given that the reactions are faster when platinum is the catalyst, it means the reaction with platinum have lower activation energy. So conversely, palladium catalyzed reactions would have high activation energies. So therefore option 2 is also correct. In the third option, the platinum catalyzed reactions are more exothermic than the palladium catalyzed reactions, as we know that catalyst does not have anything to do with exo and endothermic reaction. Catalyst only lowers the activation energy. So therefore option 3 is incorrect. So option 1 and 2 both are correct, so therefore answer is B. Question 35. Which statements about ceramics are correct? As we know that ceramics are composed of aluminum oxide and silicon dioxide. Let's move towards options. In 1, ceramics are good electrical conductors. As we know that there is no free electrons present in aluminum oxide and silicon dioxide, so therefore they are bad electrical conductors, so this is incorrect. Second option is that ceramic are strong materials. This is correct because the bonding in aluminum oxide and silicon oxide is strong and the structures are giant covalent, so therefore they are strong materials. Third option is that ceramics have high melting and boiling points. Now these structures with aluminum oxide and silicon dioxide having giant covalent structure, they withstand high temperature and provide electrical insulation, so therefore option 3 is also correct. So therefore answer is C. Question 36. Which types of bonding are present in ammonium carbonate? Let's draw the structure of ammonium carbonate. We have nitrogen and carbon. Now nitrogen is making 3 single covalent bonds with 3 hydrogen atoms, and it is making 1 coordinate covalent bond with H positive, and the charge on ammonium ion is +1. In carbonate we have carbon as the central atom. It is making double covalent bond with 1 oxygen and 2 single covalent bonds with 2 other oxygen atoms, and the charge is -2. Now the charges are balanced by using 2 ammonium ions, so therefore in the compound we write ammonium 2 carbonate. Number 1, we have ionic bond. As we can see, there is positive charge and negative charge, so the force of attraction makes an ionic bond. Second is covalent bond. As we can see, there are a lot of covalent bonds. Third is coordinate covalent bond or dative covalent bond. Nitrogen makes a coordinate covalent bond with hydrogen by giving its lone pair of electrons. So all 3 options are correct, so therefore answer is A. Question 37. The diagram shows the structure of cholesterol. This is the structure of cholesterol. Which statement about cholesterol are correct? Number 1. The molecule contains a secondary alcohol group. Now secondary alcohol is the one in which OH is attached to the carbon atom, which is directly attached to 2 other carbon atoms. So in this structure we can see this is the OH functional group, which is attached to this carbon atom, and it is directly attached with 2 other carbon atoms, so therefore this is the correct option. Number 2, the molecule contains 2 pi bonds. As in this whole structure we can see that there is only 1 pi bond or double bond, so therefore this is incorrect. Third option, all carbon atoms in the 4 rings lie in the same plane. This is incorrect because carbon atoms in these rings lie in twisted rings and it is not planar. So only option 1 is correct, so therefore answer is D. Question 38. Chlorine atoms in the upper atmosphere cause the breakdown of ozone. Now these are the chemical reactions involved. Which statement about these chlorine atoms are correct? Number 1. The chlorine atoms act as catalysts. Now catalyst is such a substance that is involved in the chemical reaction and it is not consumed and it is also produced in the product. So we can see chlorine atom is starting this chemical reaction and again chlorine atom is being formed in the product, so therefore it is behaving as a catalyst. So option 1 is correct. Option 2. The chlorine atoms are free radicals. Free radicals is such a substance that has unpaired electrons. Now in chlorine atom we know that chlorine belongs to group 7 and it has 7 electrons in the outermost shell, out of which 3 are paired electrons and 1 is unpaired. So therefore chlorine does behave as a free radical. So option 2 is also correct. Number 3. The chlorine atoms are formed by heterolytic fission of a covalent bond in chlorofluorocarbons. Heterolytic fission is the unequal distribution of electrons whenever a bond is broken. So if chlorine atom is heterolytically broken from carbon, so it will have negative charge instead of neutral atom. In this option they have given the chlorine atoms, not the chlorine ions, so therefore this is incorrect. The chlorine atoms are actually formed by the homolytic fission of a covalent bond. So option 1 and 2 are correct, so therefore answer is B. Question 39. The compounds listed are reacted with hydrogen cyanide. Which compounds produce a molecule containing a chiral center? Hydrogen cyanide is HCN, and chiral center is something that has 4 different elements or groups attached. Let's move towards the options. 1 is butanol. The structure of butanol is 4 carbon atoms and it is an aldehyde. So it will react with HCN to form this structure. Double bond oxygen will convert into OH and CN is attached with the carbon atom. Now as we can see that this carbon atom has 4 different groups attached. One is OH, one is CN, one is H, and one is this alkyl group. So therefore this is chiral center. So option 1 is correct. Second is butanone. The structure of butanone is like this. We have 4 carbon atoms and the double bond is present on the second carbon. It reacts with HCN in a similar manner. So OH is attached instead of carbon double bond oxygen, and CN is also attached with that carbon. Again we can see that there are 4 different groups attached with this carbon. So therefore this is also chiral. So option 2 is also correct. Option 3 is pentane 2-one, in which we have 5 carbon atoms. And on second one we have ketone. It will react with hydrogen cyanide in a similar manner, and the product formed will be the double bond oxygen will convert into OH, and CN is also attached with the same carbon atom. Now we can say that as all 4 groups attached are different, so therefore this is also chiral center. So all options 1, 2 and 3 are correct, so therefore answer is A. Question number 40. Carboxylic acids can be prepared from alcohols, nitriles or esters. Which statement are correct? Number 1. Both primary and secondary alcohols can be oxidized to carboxylic acids. For primary alcohol, we know that primary alcohol first goes into aldehyde, and then convert to carboxylic acid upon oxidation. Secondary alcohols do not oxidize to carboxylic acid, they oxidize to ketone. So option 1 is incorrect. Option 2. Carboxylic acids can be made from nitriles by hydrolysis. We can write chemical equation for this. Cn means nitrile, and it is hydrolyzed in the presence of acid to produce carboxylic acid and ammonium ion. So option 2 is correct. 3. Ethyl propanoate gives propanoic acid when reacted with hydrochloric acid. Ethyl propanoate is an ester. Let's write the chemical equation for this one. We have ethyl propanoate upon acid hydrolysis in the presence of HCl and water. It will convert into corresponding carboxylic acid and alcohol. The first part will give carboxylic acid and the second part will give alcohol, and the products will be CH3 CH2, C double bond O, OH, along with CH3, CH2, OH. As this is propanoic acid, so therefore option 3 is also correct. So therefore answer is C. Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.